Intake, compression, power and exhaust are four basic processes in any engine. Intake, air and fuel is taken in. Compression, air-fuel mixture is compressed. Power, air-fuel mixture is ignited, then pressure of expanding gases pushes the piston down. Exhaust, after combustion, exhaust gases are pushed out. Before going further, let us define one of the most important parameter called stroke, which is maximum displacement of the piston or distance between top dead center and bottom dead center. In a 4-stroke engine, all the 4 processes will finish in 4 strokes, whereas in a 2-stroke engine, all the processes will finish in just 2 strokes. Let us discuss the process in a 4-stroke SI engine. Intake stroke. Intake valve opens, admitting air and fuel. Exhaust valve closed for most of the stroke. Compression stroke. Both valves closed. Air-fuel mixture is compressed by raising the piston. Spark ignites mixture near the end of the stroke. Power stroke. Fuel-air mixture burns, increasing temperature and pressure. Expansion of combustion gases drives the piston down. Both valves closed. Exhaust valve opens near end of the stroke. Exhaust stroke. Exhaust valve opens. Exhaust products are displaced from cylinder. Intake valve opens near end of the stroke. In a 4-stroke CI engine, during intake stroke, only air is taken in and fuel is injected through a fuel injector just after a compression stroke. Because of higher temperatures in cylinder, fuel air mixture reaches self-ignition temperature and self-ignites. So there is no need of spark plug in CI engine. But what is self-ignition temperature? The temperature at which fuel air mixture will ignite without the use of spark plug is called self-ignition temperature. Let's see some important differences between CI engine and SI engine. SI engine works on Otto cycle or constant volume heat addition cycle. CI engine works on diesel cycle or constant pressure heat addition cycle. Gasoline is highly volatile whereas diesel is less volatile. Gasoline evaporates readily, so it gets mixed with air efficiently. As a result, just a spark is sufficient to produce smooth combustion. On the other hand, diesel does not properly mix with air. In SI engines, fuel air mixture is introduced during suction stroke or intake stroke. In SI engine, only air is introduced during intake stroke. Fuel is injected into combustion chamber at the end of compression stroke. For SI engines, carburetor and ignition systems are necessary. For CI engines, a fuel pump and fuel injectors are necessary. Modern engines have gasoline direct injections. In SI engine, throttle controls the quantity of air-fuel mixture introduced, whereas in CI engine, only quantity of fuel is controlled or regulated. Air is unregulated or not controlled. SI engine requires an ignition system with spark plug. In CI engine, self-ignition occurs due to high temperatures of air because of high compression. SI engines have compression ratio between 6 to 10 and upper limit is fixed by anti-knock quality of fuel. CI engines have compression ratio between 16 to 20 and upper limit is fixed by weight of the engine. Because of low compression ratio, the maximum value of thermal efficiency that can be obtained is low in CI engines. Due to higher compression ratio, the maximum value of thermal efficiency that can be obtained is high in CI engines. SI engines is lighter in weight due to lower peak pressure. CI engines are heavier due to higher peak pressures and heterogeneous combustions and vibrations. Now let us discuss 2-stroke SI engine. Stroke 1. Air-fuel mixture is introduced into the cylinder and is then compressed. Combustion is initiated at the end of the compression. Stroke 2. Combustion products expand and push the piston down and is sent out or exhausted. The air-fuel mixture is first drawn into the crankcase by the vacuum created during the upward stroke of the piston. During the downward stroke, the poppet valve is forced to close by the increased crankcase pressure. The fuel mixture is then compressed in the crankcase during the remainder of the stroke. Towards the end of the stroke, the piston exposes the intake port, allowing the compressed air-fuel mixture in the crankcase to escape around the piston into main cylinder. This expels some of the exhaust gases out the exhaust port, and unfortunately some of the fresh air fuel mixture is usually expelled as well. Let's see what is scavenging. Scavenging is the process of pushing exhaust gases charge out of the cylinder and drawing in a fresh draught of air or fuel and mixture for the next cycle. The piston then raises the flywheel momentum and compresses the air-fuel mixture. At the top of the stroke, the spark plug ignites the fuel and mixture, then the pressure of expanding gases pushes the piston downwards, completing the cycle. Let us compare two-stroke engines and four-stroke engines. Two-stroke has a simplified construction. It has no valves but has ports. Four-stroke engine construction is complex. A valve in an engine is operated mechanically, whereas a port is just an opening which is closed and opened by piston. Thermodynamic cycle of a two-stroke engine is finished in two strokes or in one revolution, and we have one power stroke for every one crank revolution. Thermodynamic cycle of four-stroke engine is finished in four strokes or in two revolutions, and we have one power stroke for every two crank revolution. Two-stroke engines has higher power to weight ratio, whereas four-stroke engines has lower power to weight ratio. Volumetric efficiency of a two-stroke engine is low due to less time for intake. Volumetric efficiency of a four-stroke engine is high.